Hello students, consider this part 2 of the binomial distribution section from the chapter Discrete Probability Distributions. In this section, or in this video, from this section, I'm going to show you how to calculate binomial probabilities. I introduced the formula on the previous video, but I'm going to show you that there's different scenarios and different types of formulas, different types of probabilities you're going to be calculating. I'm going to start by introducing the difference between PDF and CDF functions. The probability density function, or PDF, describes the likelihood of a continuous random variable taking on a specific value. The cumulative distribution function represents the probability that the variable is less than or equal to a specific value. I'm going to try to simplify it a little bit. Think of the probability density function, or the PDF, to be used when you're computing the probability of exactly a number. For example, if we're looking for the probability of exactly 4, that will be just you locate whatever your 4 is in your distribution. What's the probability that it's just that value? Exactly 4. If we're using the cumulative distribution function, that means we're computing the probability that an outcome is less than or equal to a value. For example, let's take the word here, at most. At most 4 means 4 or less, or less than or equal to 4, which means including the 4, I have here 4 and everything that it's before it, all of these values in my distribution. That's the difference between PDF and CDF. And you're going to be given different instructions and you have to identify which one's which. Here's a slide that includes the possible different wording you can see in your examples, and you have to decide whether you include or do not include the value. For example, if you're including the value, that means the wording for your problem use words like at most, at least, fewer than or equal to, or more than or equal to. That or equal to is what we represent with this line at the bottom of our inequality symbols. We call this inclusive. And if we're writing it in a range, we use the brackets or square brackets to denote our interval. For example, if you have from the numbers from 2 to 5, this includes numbers 2 and 5. Now, whenever you have words like less than, fewer than, or phrases like more than, greater than, and they don't say including or equal to, then that means you do not include the value. It's strictly less than or strictly greater than, and we call this exclusive. We use the symbol parentheses, the common parentheses, to denote our interval. And for example, if we write that from 2 to 5 with parentheses, that means all of the values between 2 and 5, but not including the 2 and not including the 5. That's the difference between the two. And I don't know about you, but I have always confused at most and at least. And if you confuse them, think of it, put it in terms of money. Would you like to get paid per day at most $100 or at least $100? And trust me, you will understand the difference right away. Now, when it comes to our probability distribution, if we're looking for the probability of exactly a value, your notation will be the probability of x being equal to whatever number you have. For example, if I'm looking for the probability of the x value being exactly 3, you locate where the 3 is at, and it's just where that value is, at 3 over here. That's it. If you're looking for the probability between, 2 and 5, the same numbers we were using before, that includes the 2, because it's x is greater than or equal to 2, but less than or equal to 5. That or equal to, that includes those 2 and 5. In your examples, you could see the word inclusive or including the values 2 and 5. That means you locate your 2, whatever your 2 is, you locate your 5, whatever your 5 is, and it will be all of the values between those two. Oh, sorry. All the values between the two, like this. If you have a wording of at most, they tell you at most, I don't know, at most 4. You locate your 4, and all of the values that are less than or equal to 4 are going to be your possible outcomes. Including the 4, all of the values that are less than or equal to 4. If you're being told the probability of at least some value, we use the symbol greater than or equal to. That will be all of the x values that are greater than or equal to whatever number you're thinking of. Let's use 4, since we had already used 4 before in the previous example. We locate our 4, whatever the 4 is. This is not a scale. And at least means 4 or everything greater than 4. You can also say the area to the left of a value, the area to the right of a value, the area in between the values. Now, some examples might ask you for the outer area. That will be a different notation. But in the case you get an example that gives you an outer area, let me duplicate the slide, your notation will be different. Let me delete this portion right here because we don't need this. Let's suppose you're being told the probability that x is smaller than or equal to, I don't know, 1, but if x is also greater than or equal to, I don't know, 4. That's fine. You have to locate your 1, and it will be anything smaller than or equal to 1, so the area to the left. And also, all of the x values that are greater than or equal to 4, you locate whatever your 4 is, assuming it's right here, the area to the right of 4. In this case, we're being asked for the outer area of a range, not the inside area. Now, depending on what you're asking, what your question is asking or what you're being asked to do, you're going to decide which formula you're going to use or which method you're going to use. In the following videos, I will show you how to find the probabilities using Excel, using the GeoGebra calculator, using the Desmos graphing calculator, and using your TI-84 calculator. If you just choose to see only one of them, that's fine. I just want to show you how to compute use different calculators to compute different scenarios of probabilities, of binomial probabilities. Thank you.